One question just woke a building the size of a town. It is 3 in the morning. The woman who asked, typing in a dark kitchen 400 miles away, will never see the building, and no bill will ever arrive. But the cost of answering her, one answer, a fraction of a penny, has quietly become the most fought-over number in the technology business. Multiplied by 1 billion people, it decides the profit margins of the biggest companies in your pension, and, at the end of the chain, what your own free apps are still allowed to do for you. Inside that building, her answer is paid for twice. Once when the machine was built, a training run, months of computing that costs as much as a skyscraper and happens exactly once. And once when she asked, a sliver of electricity and silicon spent on her question alone, then spent again for every question after it, forever. The builders call the first cost training, and the second inference, and the whole economics of artificial intelligence hangs between the two. And one bill in this business behaves impossibly. The one bill that keeps rising while its price collapses. The final act of this film is what explains it. $78 million. That is one respected estimate of the computing bill for a single training run of the model that opened this era, back in 2023. And its great rival's flagship was costed at nearly $200 million. A training run is a factory bill, colossal, paid up front, finished. When it ends, the model's abilities are frozen into a file, and copying a file costs nothing. If that were the whole story, artificial intelligence would be the best software business ever invented. It is not the whole story. There is a catch in that factory, and it is brutal. A trained model starts going out of date the day it opens. Within months, a rival trains something sharper, or a cheaper route is found to the same answers, and the file that costs 9 figures is quietly demoted to yesterday's machine. So the training bill is not only huge, it repeats. Every frontier laboratory is on a treadmill, paying skyscraper money every year or two simply to hold its place at the front. Which makes the other cost, the tiny one, matter even more. That one never stops, and it is never refunded. An exchange with a large language model probably costs 10 times more than a keyword search. That was Alphabet's own chairman in early 2023, doing the sums out loud while the world fell in love with chatbots. 10 times, across billions of searches a day, is the kind of multiplication that keeps finance directors awake. Analysts at the time sketched several $1 billion a year of extra cost if chat answered even half of Google's queries. The fear was never whether the machines could answer. It was that every answer now cost real money, at a scale where real money is measured in power stations. What does politeness cost? People say please and thank you to these machines. Millions of people, every day, 2 words of pure courtesy that no answer needs. Every one of those words passes through the same silicon as the question itself. Asked what the courtesy added up to, the chief executive of the company behind ChatGPT put it at tens of millions of dollars of electricity and called it money well spent. Turn the joke over and it stops being funny. In a business where good manners show up on the power bill, there is no such thing as a free word. For 40 years, software ran on a magic trick. Writing a program cost a fortune, and then every copy after the first cost nothing at all. The same disk, the same download, 1 billion times over, at a marginal cost of roughly 0. That trick built the highest profit margins in the history of business, and it is why most of the largest companies on Earth are software companies. Artificial intelligence has quietly broken the trick. An answer is not a copy. It is manufactured, one at a time, from electricity and silicon at the moment you ask. And for the first time since the floppy disk, software has a cost of goods. In 2025, Google opened its books on a single answer. A typical text reply from its assistant consumed about a quarter of a watt-hour of electricity, the energy of 9 seconds of television, plus 5 drops of water for the cooling, and a small fraction of a gram of carbon. 9 seconds of television. The number is almost insultingly small, and the smallness is the trap. Nothing in this business happens once. The only numbers that matter are the ones that get multiplied. Now run the multiplication. This year, the best-known chatbot alone crossed 1 billion users a week. 1 billion people, dozens of questions each, every answer manufactured on demand. And that is one product from one company, in a world where every search box, spreadsheet, camera, and call center is being rewired to answer the same way. Multiply 9 seconds of television by the connected population of the planet every day, and the smallest number in software becomes the largest electricity bill in the history of computing. That is what the town-sized buildings are. Factories for sentences. And who pays for it all? Mostly, nobody. Of every 100 people using the best-known assistant in a week, roughly 93 pay nothing at all. The free answers are a bet, funded by investors today in the hope of customers tomorrow, much as the free searches and free maps of the last era were funded by advertising. But a free user of old software costs nothing to serve. A free user of artificial intelligence has a manufacturing cost every single day. So the number that decides who survives is still ahead, and it is doing something no industrial price has ever done. Take one answer apart, and it is more than electricity. The true cost stacks 4 layers. Seconds of time on a chip that costs tens of thousands of dollars, the power that runs through it, the cooling that carries the heat away, and the layer outsiders miss, the idle fleet. Because a system built for the evening rush sits half-used at dawn, and every silent second of a machine that expensive is money burning. It is why the operators obsess over a word borrowed from old factories: utilization. A full data center is a printing press for margin. A half-empty one is among the most expensive buildings on Earth, doing nothing. Then the strangest move in modern business. The price collapsed. Stanford's researchers tracked answers of the quality that launched this era. About $20 for 1 million tokens, the snippets of text these machines count in, at the end of 2022, and about 7 cents for the same quality 2 years later. A 280-fold price cut in 24 months. Oil never did that. Steel never did that. Even computer chips on Moore's famous curve needed a decade for what this input did. The collapse is engineering, not discounting. Each generation of chips wrings more answers from the same watt. Big models are distilled into small ones that give the same answer at a fraction of the cost. The software squeezes the same hardware harder every month. Google reported that in a single year, the energy of a typical answer fell 33-fold. And that points at the deepest property in this whole story. The input is made of mathematics. Oil gets harder to reach the more the world wants it. Intelligence gets cheaper to make the more of it is made. A Victorian economist saw this exact puzzle in 1865. William Jevons noticed that every time the steam engine became more efficient, less coal burned for the same work, Britain burned more coal, not less. Cheaper work found new work to do. The observation carries his name now, the Jevons paradox, and it closes the question this film opened. The price of one answer is collapsing, so answers are being poured into everything, every search, every document, every photo roll, and the total bill climbs while the unit price falls. That is the one bill that keeps rising while its price collapses. It is why the grid cues from our last film stretch into the next decade, even as every single answer sips less. Read the whole trade through one lens, the gap between what an answer costs to make and what it earns. A company that owns the full stack, its own chips, its own buildings, its own models, watches cost per answer fall with every efficiency gain. The collapse works for it. A company renting computing to give answers away is running a factory with a manufacturing cost and no invoice. For it, the collapse is a race against its own burn rate. And the sellers of shovels, chips, power, buildings, are paid either way. In a gold rush, the geology decides who eats. In this one, it is the unit economics. Which brings the chain back to the kitchen. The companies carrying this bet, the model builders, the chip makers, the landlords of the town-sized buildings, are, by weight, the largest holdings in the index funds most pensions sit in. Their margins now move with a number measured in watt-hours, and every earnings call circles one question. Is the cost of an answer falling faster than the world's appetite for answers is growing? So when a free assistant suddenly rations you, or a subscription quietly rises, that is not marketing. That is the cost of one answer being passed down the chain, to the last person standing in it, you. One machine, one idea. When the next $100 billion data center deal crosses your feed, skip past the big number and ask the small one. What does one answer cost this company to make? And which way is that number moving? The big number is the bet. The small number is the verdict. This has been Under the Hood, one machine taken apart. And the trillions funding all of it are borrowed into existence somewhere stranger than any vault. Banks do not lend out the money that exists. They create new money when they lend. Where money actually comes from is the next film. Education, not advice. And I will see you there.